Good morning to one and all. My name is V. Abhijit Kumar and I am studying in CSC AIML, that is Computer Science and Engineering with a specification of Artificial Intelligence and Machine Learning, BTech first year, first semester, Institute of Aeronautical Engineering. In today's Tech Talk, with the subject of elements of electrical and electronics engineering, I am going to discuss about the topic of current sensing for automotive electronics, a survey. First of all, I'm going to introduce the topic and I'm going to explain about automotive applications of current sensing, and I'm going to explain current sensing techniques, and I'm going to compare each and every technique, and I'm going to state about challenges in current sensing, and I'm going to explain about emergency trends, and finally I'm going to conclude the topic. By the introduction, let's talk about what is current sensing. Current sensing is simply known as the process of measuring electric current in a circuit to monitor and control electrical devices, which means that current sensing is used to measure current in any given specific particular circuit to monitor and control each and every electrical device or all of the electrical devices any device required. And after that, what is the importance of current sensing in autonomous electronics? The importance of current sensing in autonomous electronics is that it ensures safety, efficiency, and performance of electronic systems like batteries, motors, sensors, and many more. Let's talk about the scope of the survey. In this survey, I'm going to discuss about techniques, applications, and challenges in automotive current sensing. Now, first of all, let's talk about automotive applications of current sensing. In battery managed systems, current sensing is helpful to monitor battery health, charge, and discharge cycles. In electric power steering, current sensing is used to measure motor current and it assists steering control, which can be helpful to make it even more safer. In electric vehicle charges, current sensing is used to track charging current for efficient power delivery, which can make the delivery of the required power or the required amount of power even more successful. And in advanced driver assistance systems, current sensing, the topic, is useful to sense currents in sensors and actuators for real-time control, which is used in a lot of places nowadays. Now let's talk about techniques of current sensing. The first technique is shunt resistor based sensing. The shunt resistor based sensing means measuring voltage drop across any specified resistors. Now the pros of this technique is that this technique is very simple and it's very cost effective. But the cons of this technique is that we have to bear a lot of power loss and it has a very limited accuracy. And the second technique is Hall effect sensors technique. This technique uses magnetic fields to measure current. Now the pros of this technique is that this technique is non-invasive and this technique is accurate. And the cons of this technique is that it is affected by external magnetic fields. So we have to make sure that it is not affected by external magnetic fields in a required way. And the third technique is to use current transformers. The current transformers are used for AC current sensing in high voltage systems. Now the pros of this technique is that this technique can be isolated and robust. But the cons of this technique is that it is very bulky and it is limited only and only to AC currents, that is alternating currents. These are the three techniques, and now let's compare each of these techniques. The method of shunt resistor has a very medium accuracy but very low cost, and it is applied in BMS and small circuits. The method Hall effect has a very high accuracy in a good way, and it has a medium cost, and it is applied in EPS and EV motors. And the method of current transformers, which we have discussed, has a very high accuracy, and its cost may vary in between medium and high, and it is applied in high voltage systems, chargers, batteries, etc. These are the comparisons of the techniques which we have discussed in a tabular form. Now let's talk about the challenges which we may face in the process of current sensing. The first challenge is the challenge of thermal effects. The accuracy which we want in the measurement can be affected by the changes in temperature which we may not want. And the second challenge is the challenge of noise and interference. Automotive environments have high electromagnetic interference, which may affect our process in a bad way. And the third challenge is the challenge of size constraints. Modern vehicles demand compact and integrated sensors a lot, which means that the sensors which are integrated and compact in a sensible way, in a definable way, are the only sensors which are being demanded nowadays by today's modern vehicles. And the fourth challenge is the challenge of cost versus performance trade-off. Balancing affordability and precision is very critical for anyone who deals with the process of current sensing. So these are the four challenges in current sensing. Now let's talk about the trends which are emerging nowadays, which are related to the process of current sensing. The first trend is the trend of integrated smart sensors. The sensors with built-in processing and communication are becoming a big trend nowadays. And the second trend is wireless current sensing. It reduces wiring completely in EVs, which can make the process a little bit easier. And the third trend is the trend of wide bandgap semiconductors. The wide bandgap semiconductors have a chance of enhancing the efficiency of current sensing systems, which we all may need someday. And the fourth trend is the usage of AI and machine learning in the process of current sensing. We have to analyze current patterns for predictive maintenance in the process of current sensing by using AI and machine learning to make it even more effective for us. And finally, I would like to conclude this topic with three key takeaways. The first key takeaway is that the current sensing is vital for modern automotive electronics. And the second key takeaway is that various techniques cater to different applications with their own pros and cons, which we may all have to deal with someday. And the third key takeaway is the challenges like thermal effects, EMI, and many more we discussed about need innovative solutions. And the future scope for this concept is that advanced sensors with AI integration can optimize automotive systems. And now, finally, I would like to thank my lecturers to give me this wonderful topic as a tech talk topic for me. Thank you.